Welcome back to my small tutorial series about graphics programming on macOS. In this one, well, first of all, I will fix the small warning. Now it's correct and we get out a float value from our absolute function. Yeah, but other than that, I wanted to take a brief moment to touch on something which is kind of non-standard, and that has to do with how I built our small project. As we see here, I include implementation files and not header files, which is kind of the standard. So most people who have seen some C++ or C code would expect including header files here. I don't do this. And to illustrate the point, I will show the standard way, and then we can compare both ways of compiling and building the project, and that will also illustrate why I'm doing this. For the comparison between a Unity build, this is what I do, and a standard build, I create two header files for the window and the renderer, and then I will extract the interfaces of both these constructs into the header files. What that basically means is I will copy out the interface stuff here and the public functions which are used in main, and mark them with this Unity build define in a way that if we are building with the Unity build flag set, we build the way we always did, and if it's not set, then the header files are used. I start off the window header file creating a so-called header guard, which just prevents including the same code again and again, even if we have already included the code. So now we can copy over the interface from our implementation into the window.h file. The errors here are simply because this is Objective-C and Visual Studio Code again recognizes this as C++ and then draws these squiggles to indicate that there's something wrong. To fix this, I will briefly say or remap header files also to Objective-C, and now we should have no warnings and errors in the header file. Same thing happens now with the renderer, so I mark up the interface and the includes with the Unity build define, and if it's not set, then we will include the renderer.h file. Now that both header files are implemented, I will now go ahead and change the build shell script and define the Unity build symbol. And first build failed. Obviously I missed adding the create main renderer and render function to the header file, and that's a problem because now without the Unity build define, our main function cannot see these symbols anymore. That's why they need to be defined here as well. Okay, now there is another problem. Undefined symbols, that means, yeah, we obviously have not added the flags to our build step. Now that we do, it works, and now we are basically back to square one. So this is the Unity build. And what I do now is I create a small function inside our shell script, which is depending on an input parameter able to switch between the Unity build and the standard build. This last line adds the time utility to our build step so that we see how long our build took. The main difference between the standard build and the Unity build is that the standard build compiles each implementation file into an object file or a translation unit, and the Unity build doesn't. It builds only one translation unit, and that leads to quite a significant speed up in build time. But yes, it also has drawbacks. If you use a Unity build, whenever you build the whole thing, the whole program. So that means things like incremental builds are out the window. But as we will see, especially for these smaller projects, the speed up is quite significant. So the Unity build took 1 second and the standard build 2.3, just to verify. Again, 1 second versus 2.3, and that's it. Thanks for watching, and until next time.